In this chapter, we focus on statistical inference for the mean when the sample size is small and the population is roughly normal. Our new friend is the t-distribution. You can think of it as the z-distribution after a few extra donuts. Same center, heavier tails. Here we set the stage for when t-procedures are appropriate. Small sample, unknown sigma, and roughly normal data. If any of these pieces are missing, t might not be the right tool. In other words, you do not summon the t-distribution just because n looks cute. Here we introduce the t-distribution formally. Same basic shape as the normal, but with heavier tails. The smaller the sample, the chunkier those tails get. As your sample grows, t basically goes on a diet and turns into the normal curve. This slide is just about how to talk to the t-table without getting lost. Pick your degrees of freedom from the left, pick your tail area across the top, and read the number where they meet. These t cutoffs are larger than the z cutoffs due to the heavier tails. But they will approach the z cutoffs as n gets larger and larger. It's just like the large sample confidence interval, except we are using the t-table now, because we do not know sigma and the sample is small. This slide gives the basic recipe for a one-sample t-test. Small sample, unknown sigma, normal population, and we test a claim about the mean. The steps are always the same. Hypotheses, alpha, compute t, compare, and then say what it means in pro language. This machine needs a tune-up before these out-of-whack metal bolts start claiming lives. A small p-value means our t-statistic is deep in the tails, so we reject the null. With our paper t-table, we cannot calculate p-values for the t-distribution. So I'll expect you to use the rejection region approach, compare t to the cutoff, rather than computing exact p-values. But if you are curious, you can use any online t-distribution calculator. Enter t, the degrees of freedom, choose one-tailed or two-tailed, and it will spit out the p-value. With two-tailed tests, saying the null mean is outside the confidence interval is basically the same as saying the p-value is below alpha. In short, intervals and two-tailed tests are just two ways of telling the same story about the data. If your sample is tiny and your conclusion sounds dramatic, the safest conclusion is usually collect more data.